Okay, let's start. So now you might remember that last session we talked about, well, we start actually explaining and assessing manufacturing techniques. And that was what we were talking about. We talk about the different cutting options for different kind of metals. I mean, it depends of the cutting technique that you want to use, and of course of the materials characteristics. So
Exactly.
you know that you can use something that it's known as drilling, flame cutting, the milling, the sawing, and the shearing. Okay.
Exactly.
So we have
Okay.
different ways, different options when we talk about cutting. Okay. So just to finish, well, no, we also finished this one. Just to make sure this exercise, in the page 24, exercise is letter C. The instructions tell us to complete definitions using the words in the box. Now, you might see that we have in this sentence 6 different vocabulary options. You have abrasive wheel, guillotine, hole saw, curve, punch, and toothed blade. And below, in number 1 through 6, you have the definition or the action of this object or of this device. So for example, a punch makes holes by applying pressure to shear the material. You know, like a punch, punch, punch until it makes holes. In this case, a punch
When you talk
punches,
about,
presses the material against itself.
okay,
Hmm.
that's the meaning. That's the meaning
Yep, of
about punch.
punch.
Okay, punch make holes by applying pressure to shear the material. Okay.
Hmm. Now you have the second one, number 2. It says, A makes straight cuts by applying pressure to shear the material.
Similar to the last tool, no? Maybe
Uh-huh.
it can be that guillotine, no?
The
Guillotine.
guillotine. Uh-huh. Guillotine, yes.
Yes, because that's apply pressure to shear. Well, it's the guillotine
Just
is
like
a good
that.
reference for that.
Mm-hmm, exactly. So let me write in here the guillotine. Great. Then as you can see in the third one, you have A is the width of the saw cut.
Is the white of the socket
Mm-hmm.
white?
The
Is the
width, yes.
white cut socket? But do you have more information about that? Because I don't know if I have
The width is
that good
anchura.
response. Okay, anchura, yeah. Well,
Of the saw
anchura,
cut.
so good, yes, so good.
Mm-hmm.
I have two words for that. Maybe you can use. Well, I can use the
Mm-hmm.
also, or
Uh-huh.
also. No, just that.
Is that one?
No, I don't know what is curve.
That's the
What happened
answer.
with that? Ah, the answer. Okay,
Yes,
well,
that's the answer. Curve.
but when you talk about curve,
You know it as corte.
okay, okay.
Mm-hmm. Actually, if you talk about a curve, is known as a cutting curve. A cutting curve
Okay.
is
Uh-huh.
like it's the definition of the
Uh-huh.
width of the material that is
Uh,
removed by a cutting
uh-huh.
process. So, for
Okay.
example, when you're cutting a component, the difference between one side and another of the cut, that's the curve.
Um,
Okay,
okay. Well,
that's the curve actually.
Next, okay. The next is number 4. Has sharp edge for curing or milling. Curing or milling. Well, in this case, it's not impact. It's not good. Yes, it's good, but I cannot milling. So in this case, maybe I can use toothed blade. Yes
A
or no?
toothed blade, yes.
Yes, toothed blade.
Yes, you know, the toothed blade is a thing that you use to cut.
Yeah.
So that's
Yes.
why it has sharp edges for cutting or milling.
Okay.
Then we go to number 5 that says
No.
that is it has a
5.
hard road
Has a hard
surface for coating or
for
grinding.
grinding. Yeah, it's more easier for that because I can use the abrasive wheel because the surface is raw. So in this
Yes,
case, the abrasive wheel is.
abrasive wheel is the option.
And
So
the
just to
last.
finish with number 6, please.
Well, in this case, I have a wholesale cuts a circular piece out to removing an intact core of material.
Exactly. As for example, when you want to put a new door at home, you use a hole set to make the hole where you're going to put, in this case, the door spattle.
Okay, okay, but you talking about when I have a lock or yes, okay,
Where you
okay,
put the lock, you made a circle in the doors.
okay, very good.
So that's the
So
main
it's
idea of
good.
this one. Exactly like this. Great. Let me erase it. And let's go ahead to what we supposed to start on today. So let me just turn page. Now, we're going to the last part of this second part of the unit 3. And just before we move on, I want to make an extension activity of more vocabulary. Okay, so I'm going to change my slide to a PowerPoint presentation.
Okay.
And there we are. So this extension activity talks about more vocabulary. Now, as you can see, you have the word and the meaning.
Okay. Well, when
So we
you
have to get
talking
the
about.
meaning of this one. So I don't know if you want to use the internet, you can use the dictionary if you have it next to you. Or if you know what the answer is, then we can answer like that.
I can investigate to the Google now to see if I have a doubt about that.
Yes,
Well,
exactly.
yes, harness is a common word for us, like engineer, because
Okay.
always we use that word. No, harness
Okay.
is like in the metal, the structure, grain or structure, talking about in raw will see or degree Brinell, but in this case I can describe that like hard material, or the structure with the I can measure the hardness in that material. No, I think is that.
Okay, so well, hardness is known as the material's resistance
See, okay.
to abrasion.
Yep, or abrasion. Okay.
That will be the meaning that we're writing here. And the same with this one, the next one, it's the toughness.
Toughness.
See, oh, it's tough. Toughness.
Yes.
It's similar to the first one. Now it's the same
Yeah.
materials resistance, but not to abrasion. To what?
I don't remember so much that word, but is the material resistance similar to
Mhm.
surface or to wear? No, or material resistance.
When you subject the material to tension and bending.
Tension. Okay. With a ductile material, or when I talk about material tension, or resistant to tension, or
Okay, that
resistant
means the resistance to breaking.
to
When you
breaking.
apply the tension or you apply bending.
Okay.
So it's that the tautness, the resistance of the material for breaking.
Mhm.
With that one, you move on to the edge quality.
Quality. When I talk about the edge, I thinking about uh, in the no form, the shape or design. Maybe I can say the design or shape. I don't know if that is the correct the shape the
You mean
shape
the
of
shape?
the materials.
Well, if according to the book, the edge quality in this case, it's known. Am I writing here? Let me see. Okay. It's known as the degree.
Okay.
You see the degree of, in this case, they told as smoothness
Okay.
of the edge
Uh,
of a material.
uh,
In this
is
case, after it has been cut.
after it been
I mean, after you cut the material, what about the edge that it stands in here?
material. What about the edge? Well, maybe it can be
Maybe it has a good cut and it has
okay.
a slim edge, or maybe it has a soft edge, a linear edge.
On other materials, no?
It of course depends of the material's toughness and hardness.
But you are talking about the techniques or the forms that you can get that value or specification in that materials because you are talking about smoothness, no?
I mean, that's how the edge in this case feels after you cut it.
Okay.
That means like the quality. I mean, not in the component specification, but just in the edge by itself. Then with that one, we move to the production volume.
Okay. Production volume. Well, in this case, we are talking about the quantity or production of the products. In this case, maybe in that manufacturing produce it or different products, no, that I can make with different process.
Exactly. In this case, the production volume is known as the amount produced, usually by a factory.
Exactly. The mass production is okay.
The mass production.
Yes.
Now in this one, look at the next one. It's a cutting wheel.
Well, when I talk or mention about cooling well, well, I thinking in a well with tooth cutting the different materials. I don't know if it can be. I can see the wood or
Uh-huh.
maybe metal or I don't know different materials that some factories can produce.
Exactly. So yes, the cutting wheel is known as a toothed wheel designed to cut materials. Mhm.
Okay. Reading. Okay. Reading. When any person mention about grinding, well, uh, fast or fast we think in the where or no nowhere in the
Mhm.
green uh, in materials when I can use with friction I can use friction for cut or for green that material
Mhm.
but using these characteristics like abrasive wall, no?
Yes, exactly. Using an abrasive wheel, in
Hmm.
this case, to cut, to
Hmm.
grind
Hmm.
away the surface.
Okay.
In this case, producing hot particles of molten metal.
Oh, exactly. Okay. Yes, because it's green. Yes,
Because of the friction.
yes, because of the friction. Okay. Combustible, but is that in Spanish? No, combustible
No, it's in
because
English.
it's in English.
Yes, it has,
Combustible.
yes, it has different meanings. Sometimes you think it as gas or a gas line, but it's not gas or it's not gasoline actually. It's
Okay.
similar to it.
If I use combustible, I thinking about in fuel or different liquid or chemical substance, chemical
Mhm.
substance. But in this case, combustible. Well, I don't see before that. But in this case, it can be maybe like a gas or diesel or flammable or
Flammable, exactly.
flammable.
That's the meaning actually. The meaning of combustible, like that
Exactly.
combustible, means that
Hmm.
it can be burned.
Okay. Ah, okay.
Just the meaning of combustible, okay?
Hmm.
I
Oh,
mean, it's
okay.
like a synonym of flammable.
Okay. Okay. Flammable. Yes.
That would be like the other word that
That's
you can
good. That's
use.
good. That's interesting. The meaning of this word because uh, we always use that kind of words
Exactly.
when I describe any characteristics or products with
Mm-hmm.
different materials.
Exactly. Now, may I erase this one?
It's okay. No problem.
Okay, okay. Now in this one, let's go back then to the book in here. And
Okay.
before we start, I want to know, what do you know about a high pressure water jet? What did
Water
you
jet.
know? What did you understand about a high pressure water jet?
Water jet. Well, it's a process, abrasive process. It's an abrasive process for
Mm-hmm.
good uh, metal or another uh, characteristic, similar characteristics to the metal or the
Mm-hmm.
iron
Okay.
through pressure water. No.
Yes, that means that you use extremely
Uh-huh.
powerful jets of water.
Okay. Powerful jets of water. Okay.
Powerful jets of water, in this case, to cut something.
Uh-huh.
And what about the word heat distortion?
What about it here? The distortion.
Heat
Uh,
distortion.
well, making we can see in when we use the hot or
The heat.
yes, the heat, and where if I can modify a damage zone
Mm-hmm.
or a damage zone, we need the control or apply high temperatures to shear any material. Thinking about for cooling or what water jet cooling is a
Uh-huh.
I think different process for that use of heat by high temperatures. No.
Mm-hmm. So yes, the heat distortion, it's known actually
Hmm.
for the changes in the shape in this case.
Changes in the shape.
In
Oh,
the
okay.
shape of a component.
Uh-huh.
Why? Well, because of heat.
Distortion. Yes, because I can say, I can think, I can in the formation of different materials like iron, the formation when I apply a heat, no, but
Mm-hmm.
it's- but it's the similar idea for that, no, when change in the shape or the
Mm-hmm.
formation of a component.
Exactly. Great. Let me just leave this in here. And let's look at the following extract of a promotional literature from a leading producer of ultra high pressure known as UHP water jet cutting machines.
Huh?
The enterprise is known as Flow. So could you please read this part of the article?
Sure. Well, what makes water jets such a popular cooking option? Water jets require few secondary operations, produce net-shaped part with no head, affected zone, heat distortion, or mechanical stresses caused by other cooking methods, can cook with a narrow curve, and can provide better usage of real material since parts can be tightly nested. No?
Mm-hmm.
As a result of the FlowMaster PC control system and intuitive operation, WaterJet are extremely easy to use. Typically, operators can be trained in hours and are producing high quality parts in hours. Additionally, water jets can coat virtually any materials, leaving a satin smooth edge.
Mm-hmm. Smooth edge. Perfect.
So, yes.
Okay. So talking about this one UHP water jet cutting machine, you can see that we have some bold words, some phrases in bold.
Uh-huh.
Secondary operations, net shape parts, heat
Mhm.
effect zone, mechanical stresses, narrow curve, and tightly nested. Mhm. So we have to get the definition of these concepts,
Uh-huh.
talking about the water jets in here. So I'm gonna change to a slide so that you can use the book on your own
Uh-huh.
to, in this case, got the meaning of these ones. You can write it on the blank space that you have on the right, or if you want to in your notebook. Now you're going
Okay.
to see my whiteboard.
Okay.
And in this case, I'm gonna write in here the vocabulary to work with. That it's the secondary, oh my God, it's a big letter. Okay, this one. That it's a secondary operation.
Secondary operation. Okay.
Mhm. They are also telling us about the net shape
Mhm.
parts.
Mhm.
They also asking us for the mechanical stresses. Oh, before that, it's the heat affected zone. Affected zone,
Heat affected zone.
and then
Zone, yes.
the mechanical stresses, and the narrow nerve, the narrow curve, please, sorry. And then after the narrow curve, we have the tightly nested.
Okay. Tightly
Tightly
nested.
nested. These are the six words, the six phrases that the article gives us in bold. So we need to think
Mhm.
about the definition of this possible vocabulary, future vocabulary words.
Okay.
Mhm.
Mhm. Well, in this case,
So we can talk out this vocabulary here.
in this case, for that process, when I talk about secondary operation, or if that mentions secondary operation, we are thinking in additional process like modifications or apply heat
Mhm.
always it can use different tools that mechanically modify the process.
Exactly. So secondary operation, it's known as an additional
Mhm,
machining, such as
mhm.
polishing, for example.
Okay.
Then maybe you can get the meaning of right from the article, but you have the net shape parts.
Mhm. Well, I can think in modify that shape, no,
Uh-huh.
in different parts. Maybe I don't know in in the holes. I can modify the dimensions, some dimensions, or in each. Yes.
Mhm.
Um, or a specification necessary for for that uh, for that for some products. No, I think is necessary that process.
Yes, now as you can see on the black and the whiteboard, the net shape parts are known as the parts with accurately cut edges, similar
Okay.
to the curve, but
Uh,
in intricate shapes. I
well, you
mean,
mentioned.
maybe it's not linear, maybe it has a weird shape or something, but
Yeah.
that is a net shape parts.
Mm, well, you mentioned that before that with high temperatures you can apply a head
Uh-huh.
or for modify different sounds, no? And
Exactly. As you said, it's the area modified by height
mhm,
temperature,
yes,
okay,
okay,
resulting from the heat or cutting.
okay, okay, yes, for the heat or coding. Mhm.
Cutting, for example. Then the other phrase that the article tells us about the water jet is the mechanical stresses.
Uh, with the mechanical stresses is interesting because you are weighing different stresses or forces that
Mm-hmm.
you can apply. It depends on material, but it depends on material. But we have um, different process. I don't know what.
Exactly. So in this case, you know the mechanical stresses as physical forces such as shear forces, when you saw or you guillotine material.
Okay, okay. With guillotine material or sewing. Okay, good.
Then we move to the narrow curve. Do you know what curve is? The distance between one edge and another when you cut. So if we
Okay.
talk about something that is narrow,
Narrow is that weight, but short weight, no?
exactly,
Narrow.
that is in a near distance, in a short
Near
distance.
distance. So it's like the water jet, or no? It's like
Similar, yes.
similar, right?
Yes.
Well, but in that case, was is when I can use to cut materials
Exactly.
like water jet, no?
Yes. I mean, when there's almost no difference in the cutting,
Huh?
that would be the narrow thickness of material removed during cutting.
Okay.
And the last one that is known as tightly nested. You know, I think that's the weird word in here, the tightly nested. I can give you the definition directly of this one because it's a little bit.
I have difficult with the nested. The tightly, I understand that the tight. Okay, try to torque or uh, apply to the force. But the nested, I have problems with that.
I'm going to give you quite the definition so that you quite understand this one. So the tightly nested, it's nested because you know the nest of the birds, the nest, el nido de un pájaro,
Okay.
the nest.
Okay. Okay.
So tightly nested refers when several components are cut together from the same piece of material.
Okay, but
Okay.
using like what tool in this case?
Well, in this case, well, in the article they're talking about the UHF water jet.
Okay, okay, yes.
That you cut in the
I understand
same
that.
material, different
Okay, okay.
components, or different pieces of components.
Okay, I understand.
From the same piece of material, the components can be placed close together.
Okay.
Like that. That would be the meaning of this one. That's why it's tightly nested, as they come from the same piece of material.
Piece of material, okay.
Like for example, when you are doing some shapes in kindergarten, and you use one sheet of paper and you cut different rectangles, triangles, squares,
Yes.
circles from one sheet of paper only. So that's like the tightly nested, okay? When you cut several components from the same piece of material.
In this case, it's very effective for that process, no? It's
Yeah,
very
actually,
effective.
because it's quite more exactly the water jet pressure, and
Okay.
of course it's faster. And in this way, you avoid having a lot of residual material because
Yes.
you try to use almost all the piece of material.
Hey. Yeah,
Okay, so let me
that's
erase
right.
this. Let me erase it in here.
In this case, is that resistant of materials.
Of course, it depends of the material's resistance and toughness.
Yes. Yep. Materials resistance.
Okay,
Yes.
perfect. Now, you can see in letter B, we are going to continue talking about the UHP, that means the ultra high pressure water jet cutting. But now you're going to listen to a conversation between Ivan and Mr. Barrett. They are talking about this water jet cutting. So you're going to listen to the conversation and match the phrases with the extract that you listen to. For
Okay.
example, they are going to talk about the heat affected zone, the mechanical stresses, the narrow curve, and the net shaped parts.
Okay.
That is a vocabulary that we just talked before.
Mm.
So listen and tell and decide in which part of the conversation, which part of the extract they mention this vocabulary. So let's go ahead and listen carefully. There it goes.
3.7. 1.
So, we use high pressure water jet cutting quite a lot. The good thing about it is you don't need to do any finishing afterwards. The edges are virtually perfect. So they're especially good when you have intricate shapes.
Which would be difficult to finish otherwise.
That's right.
2.
Saw blades are obviously useless when you're cutting curved shapes.
That's right. When you're using any sort of abrasive technique for cutting metal, it inevitably gets hot. And that can alter the properties of the metal around the cut, which can be a problem in some situations.
3.
The other problem with abrasive cutting is it exerts shear forces near the cut. So, sawing is not the best solution if you want to avoid altering the material.
The same applies to guillotining, presumably.
It does, yes.
Guillotine. Okay.
4.
It's amazing to think that a water jet can cut through steel. You could imagine water cutting timber or soft, relatively soft material, but...
No, it's ideal for metals. Actually, it's not just water that's used. They sometimes add an abrasive powder to the water to increase the cutting power.
Oh, I didn't know that.
The water's obviously concentrated into a very fine jet. Depending on how it's set up, it can take out less than 1/10 of a millimeter sometimes.
Really?
Okay, I don't know if you need me to play the listening again or that's enough.
If you can, could you do me a favor? Because one more time I can listen.
Okay.
I can listen one more time. That
3.7. 1.
So, we use high pressure water jet cutting quite a lot. The good thing about it is you don't need to do any finishing afterwards. The edges are virtually perfect. So they're especially good when you have intricate shapes.
Which would be difficult to finish otherwise.
That's right.
2.
Saw blades are obviously useless when you're cutting curved shapes.
That's right. When you're using any sort of abrasive technique for cutting metal, it inevitably gets hot. And that can alter the properties of the metal around the cut, which can be a problem in some situations.
3.
The other problem with abrasive cutting is it exerts shear forces near the cut. So, sawing is not the best solution if you want to avoid altering the material.
The same applies to guillotining, presumably.
It does, yes.
4.
It's amazing to think that a water jet can cut through steel. You could imagine water cutting timber or soft, relatively soft material, but...
No, it's ideal for metals. Actually, it's not just water that's used. They sometimes add an abrasive powder to the water to increase the cutting power.
Oh, I didn't know that.
The water's obviously concentrated into a very fine jet. Depending on how it's set up, it can take out less than 1/10 of a millimeter sometimes.
Really?
okay. Well,
Let's see.
I have the extract 2 and extract 3, but I have those in extract 1 with extract 4. But extract 2, I understand when he talk about the cut or cutting affecting one zone with a heat. So the struct 2 is a heat affected zone.
Heat affected zone, exactly.
And in the in the struct 3, well, in that case, he talked about the guillotine, like
The forces.
the forces. Yes, that process is mechanical stresses.
Mechanical stresses, great.
Mechanical stresses, but I have two doubts here because I don't understand good if that is different, because I understand that in the struct 4, struct 4 is cutting power like abrasive water jet.
Exactly.
I can think
And they mentioned at the end about the millimeters.
exactly millimeter. Yeah. Well, if that is millimeters,
So which one would be?
I can talking about a narrow curve.
Narrow curve. Exactly. The number 4, it's a narrow curve. Yes.
Okay.
Okay.
So in the last is that.
So the first one.
So the first one is net shaped parts, no?
Net shaped parts. Exactly. Great. Okay. May I erase it now?
Yep.
Okay.
It's okay.
Now we have letter C. Some phrases that ones that we have to complete by the same using the extracts from the conversation. Okay, so you have the 4. I don't know, maybe it's one phrase per extract. I have no idea actually. But you have the phrase, you have the different options, okay? I don't know if you want me to play the listening so that you complete it, or you know the answers directly through.
I think it's good listening one more time, but
okay. So listen and complete the phrases. Choose this option.
3 points.
We can do this one each one or for each one. I mean,
I don't know if it's extract 1 with phrase 1 and stuff like that. Actually, I have no idea if it goes one by one or it's a mix up.
Maybe it will be a good idea one by one. Let me check first. No.
Okay.
Let me practice that.
Read carefully.
No result. Well, we come back to the mix. Not so good. One. Okay. So. Okay. Maybe. Solid. Okay. So is not best solution if you want to buy. Good. No. Okay. And the last, I think, is totally tradable for metals. Okay. Okay.
Okay. Do you want me to play the listening?
Yeah.
Okay, listen carefully.
3.7. 1.
So, we use high-pressure water jet cutting quite a lot. The good thing about it is you don't need to do any finishing afterwards. The edges are virtually perfect. So they're especially good when you have intricate shapes.
Which would be difficult to finish otherwise.
That's right.
It's okay, especially with
2,
So I don't know if that was the answer for the first one.
Yes, so they are especially good one. You have intricate shapes. Yes.
Let's go with number 2.
Saw blades are obviously useless when you're cutting curved shapes.
That's right. When you're using any sort of abrasive technique for cutting metal, it inevitably gets hot. And that can alter the properties of the metal around the cut, which can be a problem in some situations.
I don't hear perfect when. So maybe the useless one in the initial, well, saw blades are obviously useless when you're cutting curved shapes.
Useless,
Yes.
exactly. Let's go with the third one.
Okay, thank you.
3,
The other problem with abrasive cutting is it exerts shear forces near the cut. So, sawing is not the best solution if you want to avoid altering the material.
The same applies to guillotining, presumably.
It does, yes.
4,
So in this case, the sewing is not the best solution if you want to avoid altering.
Yes, not the best solution. Exactly. Perfect. So the last one, let's see.
Okay.
It's amazing to think that a water jet can cut through steel. You can imagine water cutting timber or relatively soft material, but...
No, it's ideal for metals. Actually, it's not just water that's used. They sometimes add an abrasive powder to the water to increase the cutting power.
Oh, I didn't know that.
The water's obviously concentrated into a very fine jet. Depending on how it's set up, it can take out less than 1/10 of a millimeter sometimes.
Really?
Okay. In this case, number 4 is it's an ideal for metals. It's a ideal for metals.
Okay, idea for metals, yes.
For metals, okay.
Perfect. Perfect. Now, let me use this one and okay, we have now down below it says assess the different cutting techniques in terms, shape, size, different. Oh, actually this one would be, I think, let me see. Okay. Yes. Now, let me use my spotlight for you to tell you this one. Now, you have in here, it says, assess the different cutting techniques in terms of shape, size cut, material type characteristics, and cut width quality.
With quality.
These are the 3 terms that you are going to take in mind. The shape, size cut, the material characteristics, and the cut width quality. Of what you mean? Okay, you're going to describe all these cutting techniques. The ones that we have on the left side. Drilling, you see them? Drilling a bit, drilling with a hole saw, flame cutting, grinding, guillotining, milling, punching, sawing, water jet cutting. Actually, there are quite a lot of them. And the idea is that you can use the vocabulary that you have in here. Which one? If you are going to talk about shapes and size, you have this vocabulary. If you're going to talk about material types, characteristics, use this material, those vocabulary. And if you're going to talk about the cut width quality, you're going to use that material. Okay. So for example, the first one, it says drilling with a bit. Do you know what a bit is?
For cooking.
When they tell you drilling with a bit,
Dealing with a bit.
you know the bit, the bit, la broca.
Yeah. I know.
Perfect.
Dealing
So,
with a bit.
for example, I'm gonna give you an example, and I'm gonna write it next to it, so that you know what you have to do. It says, describe the techniques in terms of shape, material, and cut weight. So, for example, drilling, and that's how you're gonna write it on your notebook. Drilling with a bit is good for cutting blind holes. Okay, you see, I'm using the shape and size of cut. I'm using this one. Hold a second, let me change color so that you know which one I'm talking about. I'm using this vocabulary in here, you see? Blind holes.
Okay.
It's good for cutting blind holes, and then drilling with a hole saw, that is the second technique, you see? The second technique, drilling with a hole saw, is ideal for cutting timber.
Okay.
And that's another, in this case, a material type. You see that now I have the material type.
Material type.
Timber. There
timber.
it is.
Okay.
So that's what you are going to do. You're going to assess the different cutting techniques. I mean, you can decide which to use if you want to talk about shape.
For in the number 3 is flame cutting. The flame cutting is used for the cutting metals.
Okay.
So
that's a great description, actually. So you can write on your notebook, flame cutting is, let's use a beautiful vocabulary, is perfect.
It's perfect
for cutting metals. Okay. You need to try to describe, to use vocabulary to describe the materials. And for example, it's useless. Do you remember the word is useless? For cutting what?
For cutting?
The flame cutting is useless if you want to cut
wood or
wood, because it can burn. And ceramic, for example.
Okay.
So that's what you have to do, okay? To make these comparisons, using the shapes or the material or the weight and quality. Okay, that's the main idea actually of the exercise, okay? So until this part, you only need to complete the part of the grinding, the guillotine, the milling, the punching, sawing, and water jet of these 6 other phrases. Okay, so I think this will be a great exercise for you to take it as homework, so that you know and have at least a little bit more of time for you to describe these cutting techniques actually.
It's interesting, this description.
Yeah, so
I need to think that in the material characteristics and
or the shape or the result after you cut it, maybe the grinding after you use the grinding to cut, maybe you have a narrow curve, or maybe you have no curve, maybe the edges are not smooth, or maybe they are smooth. Or you can talk about grinding. Oh, I can use grinding to cut metals or to cut brittle plastics, I don't know. Or maybe you want to talk about the shape. Oh, I use grinding if I want to cut small pieces or components, or if I want to cut thick material or thick components, okay, it depends of you, or you can combine all of them. That I can use, for example, the milling is good for cutting metals, and it's unsuitable for cutting timber. And I can use the milling to cut thin materials and large pieces of material. I don't know, stuff like that.
Or is the best solution for cutting iron or cutting...
Exactly. Stuff like that. That's are the ones that you're gonna write about each material.
Okay.
That's
So
what you have to do.
in this case, it's important describe with that sentences. When you talk about a particularly suitable or best solution, if you don't want, it's necessary always combine this class of description with these techniques or characteristics.
No, I
Talking
mean
about
you decide what you want to combine, actually, the shape, the material, the cut width. And you have the phrases in the bottom box. You can see that you have in here, where is my spotlight, you have some phrases like ideal, perfect, especially good for, and the ing, especially good for cutting with ing. Oh, it's the ideal or the perfect solution for shalala. Or how it's not particularly suitable, it's not so good if you need to cut this. Maybe it's not the best solution if you want to, or stuff like that. Or it's totally unsuitable, useless, and stuff like that. So these are the phrases that you can use actually to write down the phrases of the descriptions of the cutting techniques.
Interesting.
Yes, that's the aim of this one, okay?
It sounds good, but because that's amazing when I describe the different techniques and materials. It sounds good.
Yes, actually it does. So I think it's gonna be quite a good activity for you to take its homework.
Excellent. Okay.
Okay,
Good.
that was great in here.